before we go into detail as to how to set up TUS levels, it's probably worthwhile just simply reviewing from this simple schematic on the slide what the TUS level is and how it's worked in the temperature uniformity survey. You can see here we have a schematic showing a TUS setup at a single temperature of 500 degrees Fahrenheit. You'll see that there are distinct zones, one referred to as the stabilized time. This is where the system enters the furnace and the temperature rises to the set point temperature that the furnace is running at. After stabilize, you've got the actual physical TUS time where the TUS data will be analyzed in detail. You can see here this is for 30 minutes in duration. And for this particular TUS, we have an upper and a lower tolerance limit of 10 degrees Fahrenheit. You'll see there are two traces on the schematic. There's a green trace, which is a successful TUS because the temperature rises into the stabilize zone and is within tolerance and remains in tolerance for the whole of the TUS time. The red trace is a fail because, as you can see, as it goes into the stabilized zone, there is what we refer to as an overshoot, where the maximum temperature of the red trace exceeds the upper limit of the acceptable tolerance band, which would be 510 degrees Fahrenheit. How we set up the TUS in the thermal view survey software is going to be shown in the next slide. On the slide we are looking at now, you can see the thermal view survey software. The back image shows you a TUS that's been set up at 3 unique TUS levels, which is probably very common in most temperature uniformity survey work. If we focus on the first of those, which is set up at 800 degrees Celsius, you can clearly see that within the thermal view survey software, we can set up clear defined zones to represent 1, the overshoot search, 2, the stabilize, and 3, the TUS time. This allows easy interpretation of the data, analysis of the data, and full reporting. Setting up the TUS levels is very simple within the software. What we have to do is use what we call the TUS levels library file function, and this gives you a single dialog which allows you to set up everything you need for the actual TUS that you're trying to perform. In this particular example, we have a TUS which is set up at 3 unique temperatures, 800, 945, and 1020 degrees Celsius. Our tolerance is set at plus or minus 14, which matches the furnace class that we're trying to achieve for this particular survey. And we can put in unique times for both our stabilized time and our surveyed time for the 3 respective temperatures. We can choose the type of furnace that we're performing the temperature uniformity survey on, which helps with the reporting and the data interpretation. But what is also important is this section at the bottom here where we're looking at the overshoot search. This is clearly defined within the AMS 2750H standard, linking to the data collection requirements, and this allows the operator to prove that there is no under or overshoot in the TUS being performed. There is a definition that we need to start collecting the data and analyzing the data at least 55 degrees Celsius or 100 degrees Fahrenheit below the TUS level that we're performing, and you have full control over that. The default setting is 55, but the user can select his own editable field there. It's important when we're setting up the temperature uniformity survey that we have our survey levels to comply with the operating temperature range of the furnace, and we need to ensure that we comply with the requirements as defined on the slide here in 3.5.2.2, that we have enough detail for the TUS that we're performing. Having now explained how the TUS levels work, what I'd like to do is show you specifically how to set up the TUS levels actually in the software package itself. We currently have a TUS file with 3 TUS levels already in operation, and you can see there in the database file we have in the TUS levels header the file that is associated with that. Now if I go to the settings libraries and click on TUS levels, I can see the actual currently active TUS level file that is being used with the survey that we're looking at on screen. The 3 levels, 800, 945 and 1020, these have been all set up with a tolerance of plus or minus 14, stabilization time of 10 minutes and survey time of 30 minutes. What I'd like to do now is show you how easy it is to set up a new file. Now you can do this a number of ways, but the easiest way is if you go to the header and click on there and go to the top, you'll notice Add New. I can then create a new TUS. If I need to, I can actually use an existing file as a starting point, but what I'm going to do is ignore that. I'm going to start something from fresh, so a completely new setup of a TUS library file. So the header or the title of this new TUS is new TUS 2. Now what I would then do is I would add my levels. So if I have a survey with 2 levels, I can set up the temperature. So for instance at 100 degrees or say 600 degrees, and the second level is 800 degrees. I choose what my tolerance is, my plus or minus acceptance band on those respective temperatures. So I would say 14. Put that in for both. And I then have to choose my stabilization time. The default is 15 minutes and the survey time is 30, but I can edit those to whatever I want them to be if I want them to be different. You'll see in the bottom left hand corner I can choose what furnace class library file I'm going to use. I'm not going to explain how that's set up now, but in a later video we cover that so you'll know how to set up the specification for the furnace class. But I'm going to choose the standard AMS2750 match TUS file that I've historically created. I've got a semi-continuous furnace. I'm going to have no rounding, and the default overshoot, which I'm happy with, is 55 degrees below the TUS temperature, so I'm going to use that. If I'm then happy with that file as it stands, just check I've got all the parameters in there. Yeah, that seems to be okay. In order to save that, I would press finish. Now, in order to access that new file, I would simply go to TUS levels. I would pick the file that I've generated, so new TUS 2 I think it was called. See if I can find that. There we go, new TUS 2. And I would then press the apply to current survey button in the bottom right hand corner. I shan't explain how the data is then manipulated because that's in another video, so I would suggest you look out for that later. So there we have it, simply setting up the TUS level file for easy application for your run. And remember that the library files can be set up for all your processes so you can instantly access what you need for each and every TUS that you're performing.